All right, really quick, team. I want to not take up too much of your time, but I want to go a little bit deeper from Edmentum and talk about this thing called the derived unit, right? We just learned that SI units, right? We learned SI units for things like the meter is the SI unit for what? Length. What's the SI unit for distance is length. What's the SI unit for time? It's the second, right? Those are things that you just went over in your Edmentum, but I want to take those SI units and talk about what happens whenever we put SI units together. What do they create? Let's use those two examples I just talked about, and let's talk about speed. If you guys remember back from physical science, speed is, oh, why did I write a D? Nope, speed, velocity, or speed, V, equals distance over time. And if you're like, Mr. Lee, and velocity is displacement over time. Yes, obviously it is. I'm using distance as D, displacement would normally be X. Anyway, velocity is distance over time. So let's break this down. What is our SI unit for distance, AKA length? Pause, think about it. What is it? Good job. If you're here, that means you got it correct. So the distance distance SI unit is the meter. Right? Now let's break it down. Time, what is the SI unit for time? Pause, break it down. Second, right? So we took our SI units of distance and second, and we broke that down to be what? Meters per second. Hooray, right? Awesome. So what we've just determined, we've derived or gotten to a certain point from another point, aka what derived means. We've derived the SI unit or the SI derived unit for velocity, right? Velocity's derived unit would be meters per second. Let's look at another example of where we use a derived unit, right? Because let's talk about volume. I'm going to really poorly draw a cube. Wow, let's start over. All right, so I'm going to really poorly draw a cube. Oh, one more time. Really poorly drawing a cube. Wow. You know what? We're committing at this point. It's really hard to write on this thing. Boop, boop, merp. Boop, 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 boop. Now, congrats. You are witnessing the worst cube drawn in human history. Anyway, so what is the volume formula for a cube? You should think back to your old math days. It's what? Length times width times height. Right? L times X, or I'm sorry, L times W times H. So let's say the length or the height of our cube is 1 meter, right? So that's the height. The width of our cube is 1 meter, right? And we'll go the length of our cube is 1 meter. All sides are equal, AKA a cube. So if we take those three values, what's 1 times 1 times 1? It equals 1. Boom. Now, but what happens when you take meters times meters times meters? Because your units always follow you everywhere you go unless they cancel out. You can never forget about your meters, or you can never forget about your units. So we're going to take 1 meter times meter times meter becomes what? Meter cubed. So the SI derived volume or derived unit for volume is actually a meter cubed. Now you say, well, Mr. Lee, when we talk about volume, most of the time we're talking about liquids. Yes, you are correct. So we have what are called accepted values or accepted units, right? The SI kind of accepted unit now is the liter, right? You've probably heard that term before, the liter, right? It is the SI unit, and so it is part of the metric system. Right? So it follows those same rules of you can have a milliliter, which 1,000 milliliters. Wow, if I could draw 1,000 milliliters is equal to 1 liter. You can have a deciliter. You can have a centiliter, technically. You can have a kiloliter. Now, you don't really see them. Most of the time, we just deal with milliliter and liter. So we have these accepted units. The technical derived SI unit for volume is the meter cubed, but for chemistry class, we're hitting these two. In physics, we'll handle that a lot more. We are going to talk about centimeters cubed a little bit this year, but I just wanted to introduce what a derived unit is, where it comes from, so that moving forward, when you see a liter and a milliliter, you know what we're talking about. We're talking about 1,000th of a liter, or 1,000 milliliters equals a liter. So we're going to talk more. Make sure you've watched that Edmentum before you watch this. Obviously, it's a little too late now, but that's it. There are questions that are going to be associated with this on this Ed puzzle, so please do that. Other than that, check your assignments, get your work done. Peace.